Welcome to this tutorial on the insertion sort. In this video, I will be discussing one of the simplest and most intuitive sorting algorithms out there. Whether you are just started out with computer science or you want to learn more about sorting algorithms, this tutorial will provide you with a comprehensive introduction to insertion sort. Insertion sort is an easy-to-learn sorting algorithm that operates by iterating over an array and constructing a sorted subarray from left to right. It is an effective algorithm for sorting small data sets and is frequently used as a fundamental component for more complex algorithms. This algorithm separates the array into two sections, sorted and unsorted. The sorted segment of the array is constructed by inserting unsorted elements into their correct position in the sorted segment. In the insertion sort algorithm, the sorting process begins by considering the second element of the array and comparing it with the first element. If the second element is smaller than the first element, they are swapped to put them in the correct order. The algorithm then proceeds to the third element, compares it with the first two elements, and inserts it into its correct position in the sorted subarray. The process continues in this manner with each element compared to the previous elements in the inserted subarray and inserted into its appropriate position until all the elements are in their correct position. This step-by-step approach is what makes insertion sort an intuitive and easy to understand sorting algorithm. Insertion sort has a time complexity of O(n) squared, making it inefficient for large data sets. However, it is efficient for small data sets, and its performance can be improved by using some optimization techniques. For example, using binary search to find the correct position to insert an element can reduce the number of comparisons and swaps. In general, insertion sort performs well on partially sorted data as it requires fewer comparisons and swaps than other sorting algorithms. I'm going to show you a few steps on how insertion sort works before I show you an example in Python. To sort this array using insertion sort, we start by comparing the second element, which is 2, and compare it to the first element, 5. Since 2 was smaller than 5, we swap them to put them in the correct order. Next, we consider the third element, 4, and compare it with the first two elements, 2 and 5. We shift the larger elements one position to the right to make space for 4, and then insert it into their correct position. We continue this process for the remaining elements, considering one element at a time and inserting it into its correct position in the sorted subarray. After the final iteration, the array is finally sorted. This simple example illustrates how insertion sort works by building a sorted subarray from left to right. While this algorithm is not efficient for large data sets, it can be useful for small data sets or for a building block for more complex sorting algorithms.
And I hope that gives you a good brief overview of insertion sort. So first, what we're going to do is I'm going to code the array. So we're going to do that array is equal to, we're just going to do some random numbers. And right here we're defining the array called ARR that contains, in this case, 6 different integers. And then I'm going to create a print statement that this is the pre-sorted array. I'm going to assume you guys already know basic Python. And essentially what this is, it prints a message followed by the contents of the array. Alright, the next part of the code defines an array called ARR that contains the 5 integers and then prints a message followed by the contents of the array. Right here, that's the print statement. And this is just to show you what the array will look like before it's sorted. Okay, for the next portion of the code, we're going to basically define a function called insertion sort, and that's going to take an array as its input. The function will use an insertion sort algorithm to sort the array in ascending order, and here's how it's going to work. First, we're going to have an outer for loop that iterates over each element of the array starting from the second element. This is at index 1. For each element, the algorithm saves the element as key and starts a backward iteration from the previous first element, in this case the index I minus 1, to find the correct position for the key, which is going to be save the the key is going to save the current element as the key. And once the correct position for the key is found, either because the previous element is less than or equal to the key, or because the backward iteration has reached the beginning of the array, the algorithm will insert the key into the sorted portion of the array at the correct position. So we're going to what this is, it's going to we're defining the function called the insertion sort that takes the array as its input. Now we're going to create the for loop. We're going to do that for the length of the array. And right here what's happening is you're going to loop over the array from the second element to the last element. If we start at the first element, obviously that would be 0, but in this case this is the second element, 1. What this key is doing, it's going to save the current element as a key. Next, we're going to set J to the index of the previous element. That's what this is right here. We're setting J to the index of the previous element. Now we're going to loop over the sorted portion of the array to find the correct position for the key. J plus 1 is equal to array at position J. And what this is doing, it's going to shift each element greater than the key to the right. So I'm going to clean this up a little bit. Now we're going to decrement J. Here we're going to insert the key into the correct position. Then we're going to return the sorted array. The next part of the code is going to be called insertion sort function with the array, the ARR array, and it stores the sorted array in a variable which is called sorted underscore ARR, and then the code is going to print a message followed by the contents of the array. And this is calling this right here. What we're doing is we're going to call the insertion sort function with ARR and store the sorted array into sorted underscore ARR. Then we're going to create the print statement. And what this is going to do is going to print a message followed by the contents of the sorted array. We're going to run it. And you can see right here, this is the pre-sorted. Well, I wrote pre-sorted array, but you get the point. 3, 2, 5, 8, 3, 4, 3, 2, 5, 8, 3, 4, and this is a sorted array. 2, 3, 3, 4, 5, 8. So as you can see in the sorted array, it sorted all of the elements. Thank you for watching my video. If you guys have any other questions, feel free to comment below and I'll try to get back to you guys. Other than that, thank you for watching.